So after hours and hours and hours of mental anguish, I have finally come to a decision on what we're going to do with our transmission oil cooler. I had originally planned on having a water jacketed cooler that we got off of an old Detroit V12. And I decided to, after the plumbing, thinking the plumbing out and all that kind of stuff, that I decided that we'd go with a air hydraulic cooler for my transmission. Currently, if you've seen in the videos, we just have the cooler circuit out of the retarder just looped, so we have no cooling right now, but we're only driving at 100 feet, so it's irrelevant. This cooler here, don't ask where I got it. It just was on the shelf. I saved this kind of stuff for you just never know. It has a value. So what I'm going to do is, from the other video, we have our blow fan, and the air is coming from the engine side going this way. What we'll do is we'll affix this. My plan is to affix this hydraulic cooler up on this top portion of the radiator, mount it to my two sides, which are actually really nice that they were built into this radiator structure that I also just happen to have. And then we'll run the hoses up from the bottom, and they'll both come right up here like this, and all will be well with the world. Let's get started. A lot of coolers have just a straight out.
Yeah.
But this thing is so old, it's like, this is actually National Pipe Thread. Nowadays, this would all be, well, it would typically be O-ring Boss, so that you can position your 90 without trying to pipe into obviously very thin aluminum. So not a great cooler. This machine was from, I'm gonna say the 80s. We pulled an engine out for a different project, but while you're in there, you also pull like a cooler and a radiator just to have, just in case. So this is not my first choice. If we were making something that was like, had to go, had to be perfect, we wouldn't use this kind of stuff. We would have a different budget as well. So on this one, the radiator has a built-in flange, which is pretty substantial. This cooler has an aluminum 90 built on, a straight. So what I was thinking about doing is boxing that, drilling this way and this way, using square tubing to give me structure on both sides. So that'll be nice. So I'm using this 1-inch square tubing on that side to give rigidity to two flats. I'm going to do the same thing here. I'll run a 1-inch square tubing on this. I'll run a 1-inch square tubing on this, and then I'll box frame it with the 1-inch square tubing. And that'll give me a very rigid platform to keep the thing from doing this. And then if it's still not enough, if I'm not satisfied with its movement or vibration, I will take a plate from the side and weld it to the side of the square tubing, and then I will have a 90 degrees, and that would make it extremely rigid. That's what we're going to do. Let's get started. Alright, I'm going to use these three. We'll go 26. 26 and 23. First one always lines up. If I was me, and I am, I would really be impressed with this.
Drilling 3 bolt holes in a tube is impressive, not the motor mounts or anything like that. This is the thing. This is the...
Yes, this is This is what separates the men from the boys. Drilling 3 holes with the drill press.
Yeah.
All right, let's see where these bolts are, because that's the height I want. Two. All right, we're gonna drill these 3. So what we're gonna do is, I had it like this, and with bolts going through, but it's gonna be sucky. I can't weld the nut on the inside. So I'm gonna put the bracket on the outside, then we'll drill through, and then I will weld the nuts to the inside of this beam, so when we take this off, I don't have to get my hand in there. So we're gonna reposition this.
Yeah, so now that beam doesn't ever leave.
It won't have to, correct. And that's the thing that happens when you design stuff. When you design stuff on the fly, it's surprising how many minor changes like that make a big difference in serviceability. Now, I don't expect to have to do a lot of servicing once we build this thing because of the hours it's gonna get. But it's funny how much time your mind spends in the background figuring stuff out before you show up to work. I want you to mark it towards the top side so it's actually resting on it. Like, go down, split, yeah. Trace the whole hole.
Is it dead? Oh, this is really shitty. I am not a lefty, so this is fun.
So I'm gonna be welding these 3 nuts here so that when I put my bracket up there, I don't have to get my big fat hand in there. All this will come apart again once we start painting, because all this will be sanded and painted just to get it so it's not virgin steel out there rusting away. Nice. That's great. So, because it's a narrow flange, you still have this. And that's what we need to accommodate over on this side so that we don't get both sides flexing. If I have to tie in from here all the way across and then build it up like that, I will. That's not the end of the world. But that's why I'll extend this down the full 26. So if I have to make a block, which to be honest might be the best thing to do. See?
Yeah, instead of going along out this way,
Yeah.
you're saying just tie that to that end so that you
Yes.
have rigidity in your flange.
Yep, and you know what? I think we'll do that because we're gonna be hanging a two number 20 hoses, which are heavy, and then we need this rigid enough so that when we're working with the hoses, mounting those, that's not affecting the radiator. The
Yeah.
radiator's rigid. Then the other thing about that is more is better. When this thing is full of oil and you have everything going on, this is reasonably heavy. So that's why I'm not using like 1/8 inch angle iron and stuff like that. So what I'll do is we'll box it here, go with it on the inside, and then bring this pipe or this square tubing to the inside of it.
Yeah.
We'll see how that goes. I think that's the answer. $34 3/8. Okay, so now, boy, that's gonna give me an enormous amount of structure, isn't it?
Yeah, that's already enough, I think.
Yeah. So we'll go up like that, and then we'll figure out here to here. That's with no support up here.
Yeah, you kind of already fixed it.
Yeah. I mean,
Well, because the structure is now through the radiator, right? Because that's what ties it all together.
yes, without this in here, the structure would have been this. And I prefer to have this not be the structure.
Yeah.
Prefer to have a structure that this bolts to. And this is the piece that sealed the deal. So we'll box this from here to here, and then that'll be
That'll be
it. Yep. Okay, there you go. That's my mount. The last step will be to totally take it off, do 100% welding, grind it, paint it, reassemble. And what I could see is possible need for a fuel cooler, possibly. Maybe the bevel gear case steering clutch assembly is air cooled as well. Maybe that's a small one down here. I really don't know how hard we'll have to work on this before we have a heating issue.
Yeah.
So that'll be fun.
Yep.
That's testing. I went to the hose shop, had some hoses made, bought some fittings, and now we're gonna hook the transmission oil cooler to this. The transmission output is a number 32, schedule 61, split flange mount, and I'm going down to a number 20. The original transmission, the typical Allison 5000 series has a number 20 oil cooler line. When they put a retarder on it, they jump it up to a number 32 line because of the retarder flows and the heat and all that kind of stuff. We're just going to adapt it down. The retarder on this transmission is barely going to be used, and if at all, this is such a light rig, I don't expect any excessive transmission oil heating. So let's get started and lay this stuff out, and I'm going to have to make a couple of adapters because nobody really has what I need in stock, and then the options are unavailable timely. So let's get started. Now, originally, this transmission in that time frame typically had Aeroquip, reusable fittings, medium pressure stuff. The problem is that I still don't have the adapters that go from a 32 down to a number 20. So I figured I'll spend the money, have some new hoses made. This is one of those things I don't want to use, even if I had the stuff. I didn't really want to make an Aeroquip line with 25-year-old hose. This is in the belly of the beast. I really don't want to do it ever again. We have the bottom to the bottom, so that can be,
Just a 90.
yeah, can I be that tight? If I can be that tight, which seems a little tight, because I still need the split flange there, otherwise I gotta go out. I think I'll go out like this just because. That still puts me out that far. I like that.
Yeah. That was kind of the planned spot.
Yep. Let's make the bottom one first. So I'm gonna make the bottom one, position it. These hoses will all be tied up and fit. So I'm gonna get one of these flanges here, cut it off of the pipe, then fit this in, and I'm gonna weld this fitting to that number 32. My shop only had one of these, but then nobody had the right 90. I could wait, but I'm really impatient, and currently I'm impatient, and I'm going to just make my own fitting. Cool. This isn't, torque converter out is not a high pressure setup. It's like 100 PSI on the high side. Different machines have different pressures on the torque converter and retarder circuits, but I know that I'm not worried about fitting failure or hose failure or any of that kind of stuff. Oh, that oil is filthy.
Why do you think it's so filthy?
Well, I got a lot of water in it, sitting there for 10 years. So the retarder here, the retarder is not in play until you divert the oil from converter out into the retarder. The retarder's got a big aluminum impeller that's connected to the turbine shaft. And the turbine shaft ultimately is connected to your output shaft as long as you're in gear. So what they do is they take converter out and they divert it into this housing, which it basically shoots the oil against an impeller, and it's like a boat. You know, when you put a boat in gear, how it's always working. It's that principle. You're creating a high level of load against a shaft. But when it's not being diverted to the retarder, it just goes right out like the retarder doesn't exist. It goes just straight through the valve to the cooler, back into sump. And it has a money-back guarantee. I guarantee there's no money back. The problem with hydraulic lines is you can't tell if there's pressure inside of them, right? Like on a backhoe, a static hose, you don't know if it's got zero pressure or 2,000 psi in it. So this hose here is when you loosen this, as soon as it breaks the seal between the JIC coupler, the pressure bleeds off this port here, which is really nice. One of the reasons we didn't go with the water jacketed big bundle cooler that I originally pulled out for this is because I didn't want to lose all of this area and have to do with a whole lot of plumbing. Obviously our batteries aren't going here, that's not our fuel tank long term, but I didn't want to lose access to mounting on the floor. I didn't want to fill it up with stuff that I could do in another way. And being we weren't using the retarder to slow 100 tons going down a hill for a minute, I didn't need it. So that's why we switched gears, spent less, and saved a bunch of room.
Well, that's a real special piece.
This hose end is a diverter for a transmission cooler. That's obsolete. You'll never find that. This is off of an Terex from probably the 1970s. It's long gone. So I might keep this, throw it in the box, because one of our other projects, I have a V12 twin turbo that I have in mind for something that we might figure out. So I might use it there. I could just weld it, but then I don't really have a good welding flange on the inside.
Yeah. And is it more restricted or no? Or is it the same?
It is more restricted. So, but you'd be surprised. So the flow characteristics, it's surprising, and there's some good information out there, and I can't recite it, but even though we have, say, a 1-inch opening, and this is, say, 3/4 inch, as long as that's not a long-term reduction, like where it's like a foot of that, your flow won't be hindered at all through a single opening like that for short term. It's really staggering. It's like it does restrict, but then if you could see it in a glass tube, it has a different flow, but the gallons per minute is basically identical. The other thing is, years ago I used to be a better welder, but ever since I started needing reading glasses and stuff like that, it's like, it's not as perfect as it used to be. Couldn't have asked for kind of a better setup. Okay, so that's where those should go, right there. I'm gonna find my angle here so I can weld a flat to it. Just a little bit of an angle. we should,
We should do one on that front mount.
yep. So I like to do these kind of things one at a time. So now we secure this, keep the clamps loose, do the next one, keep the clamps loose but hanging.
Yeah.
So I know how much hose I gotta deal with. And remember that ideally I like to build this hose, lay it out, and then build it when I know exactly how long it is. But I had to use a dummy to just, we just guessed, at the, made an approximation on the length of these hose assemblies. So you expect one to be tight and one to be loose, and it's just not a perfect science on that. Okay, so,
Out of my own curiosity, so we're just gonna go from that engine mount to that front engine mount.
Yep.
Are we gonna put a middle one? No, that should be
No.
enough. We're not gonna.
it should be. It should be, because if our brackets are strong enough, 4 feet is acceptable.
Yeah. Okay.
Especially since it's not rubbing on anything. If it was next to something where you gotta protect it. But when you look at some of the machines we work on, it's like, yeah, I get a harness having it on an engine every 12 inches or around corner, stuff like that, but
A straight shot like this.
we're actually completely open and in a dead spot. It's really ideal for us. And again, we're not losing any of this floor space. Even if it's not used, it's not cluttered. I don't like clutter. This one's gonna be out farther. So to be honest, we could just have one off of this bracket right here. Wherever my hand is.
Yeah.
I think.
And that'd be it.
And then I could put one more up here if I need it, but this is totally open, so,
Yeah, and it's gonna be open.
yep.
Cause you don't care about like this being like a perfect straight, and it's just.
Well, no, it's all about this curve so that the spacing's right for that. Because if this is coming out like this, I've got the room,
Yeah.
and just having it here is an obstruction, but with wind going around it, it is a transfer point. And, you know, this doesn't have to be, we can use 2 different holes.
Yeah, I think we have to on this
And I
one.
can, so if you do like it there,
I like that hose there.
okay, so let me mark it.
Drill a hole, put a zip tie there.
Yep,
I think these need to be in different holes.
I do too.
Uh-huh.
Okay, why don't you give me some small zip ties? I can gobble up some hose there.
It's just dragging against the ground.
Yeah, like that. But I can,
Oh, but if you tighten it, we could zip tie it.
exactly.
Zip tie it to the other one. Now it's not hitting the ground.
And I can pull the hose out the back.
Yeah.
So now I'm just worried about this, because I can't have it touching. So the clamp could be, what do you think of that?
I think that's good.
Okay, grab,
Your pen?
and we might be able to use the same bolt hole, but one clamps on that side.
Yeah, yeah. I see that too. I just,
Yep. Well, you don't know until you do this.
yeah.
And we can get rid of some hose length by doing that kind of stuff.
Yeah.
So this is kind of how I imagined it. No loss of space, nice and tight.
Harnesses make it look cluttered, but it's really not. You know what I mean?
Right.
Yeah.
Once you're around that stuff, what you see as clutter is nothing now.
Yeah.